In this video, I'm gonna talk about Etherchannel. So as you can see here, Etherchannel is a technology that allows you to bundle multiple links into a single logical interface called port channel. There are two Etherchannel protocols, and one is port aggregation or PAGP. This is a Cisco proprietary, and the other one is link aggregation control protocol or LACP. This one is a standard industry standard or 802.380. So there are a few benefits of Etherchannel, and one is it allows higher bandwidth between switches. Of course, when you bundle multiple links into a single logical interface, then you're going to have more bandwidth between the switches. Number two is provides load balancing, that is distributing traffic on multiple links based on a hash algorithm, but not equally balancing traffic. Number three is it creates redundant links. Of course, you have multiple links, so when one fails, the other one can the reserved links can take over. Number four is provides an optimization to STP by enabling all member ports to be placed into forwarding state. Let me read that again. So it provides an optimization to STP by enabling all member ports to place into forwarding state. So from STP perspective, when you bundle multiple physical links, STP sees it as a single link. It doesn't see the physical links, the multiple physical links, but only the logical one. And I've listed some verification commands here. So in this video, I'm just gonna focus on configuring layer 2 Etherchannel. So I've prepared the configuration here. So we're gonna configure a layer 2 Etherchannel between AS1 and or access switch 1 and distribution switch 1. So this is the only, we're gonna focus on this link here between access switch 1 and distribution switch 1. So we've got other port channels as you can see here. So these are all layer 2 port channel, but this one is a layer 3 port channel. Well, again, I'm going to talk about it in the next or future video. So let's go ahead and configure switch 1. So I'm going to go to switch 1. That's disk or distribution 1. So I'm going to do a show IP interface brief. So as you can see here, this is a port channel. This is a layer 2 port channel. So I'm gonna go ahead and configure a layer 2 port channel. So we're just gonna copy and paste this command. So, oops. So interface range, it allows you to configure multiple links at the same time. so you don't have to configure it individually. So switch port, I'm gonna copy this command here and paste it. And so basically channel protocol channel protocol channel group channel 1. Okay, so in this case you don't have to specify the protocol, as you can see in the configuration. In my configuration, I did copy and cut and paste the config. So it's fine just to configure channel group 1 mode and just select LSCP, and it's gonna, and the protocol will be LSCP. So LSCP stands for Link Aggregation Control Protocol. So when I enter this command, it's gonna create a port channel. Oops, not actually LSCP, active. So active. So as you can see here, it creates a port channel 1. So that's how, I mean, that's when you can configure that port channel interface. So I'm gonna do a show IP interface brief. So here, port channel 1. So we're gonna go ahead and configure it. I'm just gonna copy and paste these commands. Save. So now we do have a port channel 1. Let's go ahead and take a look at the show configuration or show run output. So this is the port channel 1 configuration, and this is the ports that we configured. So by the way, when you configure active, that means that it actively asks the neighbor to form a ether channel between the neighbors, or between the links. So let's go ahead and configure switch or disk 1, distribution 1. Enable. Let me go ahead and do a show IP interface brief first. So we have a layer 2 port channel here, port channel 2, and a layer 3 port channel. We're going to talk about this in the future videos. So I'm going to go ahead and copy and paste these commands. Let me see if this is gonna work this time. No, doesn't work. Do a question mark. Oh, it's actually channel protocol. Channel protocol. LACP. There you go. And this. So it created a port channel 1. So we're just gonna copy and paste these commands here. And save. I'm gonna go back to switch 1 and actually configure the interfaces. Switch 1 using so channel protocol LACP, enter. So let's see if the port channel is now up. It's now up, as you can see here, and you just have to make sure that the port channels or port channel ports have the same configuration on both switches. So I'm gonna do a show run here on distribution 1. And we're gonna compare the configuration. So, and here's switch 1, access switch 1. So that is the configuration here. So these are the physical ports, and these are the physical ports on disk distribution switch 1. And port channel 1, port channel 1. They do have the same configuration, so we can do our verification commands now. So on access switch 1, show Etherchannel summary. So this is our port channel. So S stands for layer 2, and U stands for in use, and P meaning that these ports here are in the port channel, and the protocol is LACP. So we should see the same on this switch, Etherchannel summary. Yeah, they do have the same output. I mean the output concerning port channel 1. So here. So let's do show interface port channel 1. So now we should see that the bandwidth is higher than 1 gig because the interface is gig. So this is actually about 2 gig, right? We should see the same on this switch, disk distribution 1. So show interface port channel 1. So they are the same, and you can actually verify the load balancing by using this command here, load balance. So and Etherchannel load balance. So both switches are using source MAC address. I think this is the default load balancing configuration. So yeah, that's it in this video. Thanks for watching. Bye.